Hi, Year 10. So you've just watched two videos, one about the history of the atom and the next one about the gold foil experiment. And hopefully this is the kind of summary that you would have got. So Dalton seeing it as a solid sphere, Thomson seeing the atom as a solid ball of solidness, which is the cake, with the plums or the raisins in between, which is the electron. So he saw protons and electrons, particles that were eventually known as electrons. Rutherford, through his gold foil experiment, worked out that the nucleus was a very small part in the atom, and that's where the protons were found, and around it were the electrons. And then Bohr came up with the idea that we study nowadays, that the protons and neutrons, the protons are in the middle and the electrons are in orbits or spheres traveling around the nucleus. And it wasn't until Chadwick came along in 1932 that he worked out that actually in the nucleus there were protons as well as neutrons. So Chadwick's claim to fame is the neutrons. Now, in the gold leaf experiment you watched, hopefully you made some notes, but here's some key points that we have written down in class that I need you to write down as well. So if you can pause the video and write down these points. I have seen the gold foil experiment asked as a 6-mark question, so you need to be able to explain what happened, so the alpha particles being shot to the gold leaf, what happened, some going straight through because atoms are mostly space, and why those other ones were deflected. So pause the video and copy these notes before starting. Okay, so Year 10s, what we're going to do now, and this is revision of our chemistry that's really important for this topic on radioactivity, we're just going to have a reminder of the structure of an atom. So we know that the atom, it consists of 3 types of particles: the protons, the electrons, and the neutrons. And the protons and the neutrons are found inside the nucleus. So hopefully in your books you can pause the video and you can label these structures. Now, can you remember back from your chemistry, what is the mass of a proton, neutron, electron, and what is the charge? So draw the table, fill it in, and then you can restart the video and purple pen it. Okay, how did you do? Nice and easy? I hope so. So hopefully the proton has an atomic mass of 1, the neutron has an atomic mass of 1, and the electron is so small it doesn't count. So it has, in fact, has a mass almost 2,000 times smaller than the mass of a proton. And the charge, protons are positive, P for proton, P for positive. Neutrons are neutral, they have no charge, and an electron is negative. And remember, in an atom, you've always got the same number of protons as electrons. So purple pen that, and then you can continue the video. Okay, so Year 10s, for this part, I just need to remind you about your periodic table, and hopefully you've got one nearby that you can grab and use for this. So if you remember, on the periodic table, there's the big number at the top, that's the mass number. Remember, when Mrs. Gale gets on the scale, it's always a big number, okay? And the small number is the atomic number. Now, the atomic number tells me the number of protons, and in an atom, the number of protons equals the number of electrons. The mass number tells me the protons and the neutrons, because those are the particles that you've just said have a mass of 1. So if I want to work out how many neutrons I have, I go atomic mass minus the protons, which is the atomic number, and that tells me how many neutrons I have. Okay, so I'm just going to go through, fast forward through the next 3 slides. So here you can see different elements have a different atomic number, and actually that atomic number is unique to that element. So carbon will only ever have 6 protons. Okay, now we're not going to do this because you have done this before in chemistry, so I'm going to go on to this. Over here we've got 3 different types of carbon: carbon 12, carbon 13, and carbon 14. Can you remember from chemistry what they're called, everybody? They're called isotopes. Okay, so they all carbon, but they've got different number of neutrons. And I know that because if I go 12 minus 6 for the first one, I've got 6 neutrons. 13 minus 6, I've got 7 neutrons. and 14 minus 6, I've got 8 neutrons. So you need to be able to define, even for physics, what is an isotope. So an isotope is the same element but a different mass number because it has a different number of neutrons. Okay, so it says here, what do we call isotopes that are unstable and emit radiation to become more stable? We call them radioisotopes. So carbon-13 and carbon-14 are radioisotopes. Now, let's have a look at this, and I'm going to ask you all to copy this down, and we're going to complete the gaps, and that will bring us to the end of this lesson. So year 10s, for the final bit of notes we're going to make for today, we're going to talk about isotopes and ionization. So what I'd like you to do is I'd like you to copy this out and fill in the gaps. So it says over here, isotopes are atoms with the same number of protons. Okay, that's the atomic number, but a different number of neutrons. So if it's a different neutron number, the mass number is going to be different. All elements have different isotopes, but they're usually one or two stable ones. The other unstable isotopes tend to decay. So you remember we've been talking about radioactive decay. So the unstable isotopes are the ones that decay into other elements, and they give out radiation as they try to become more stable. And this is what is called radioactive decay. So hopefully now it's all fitting together. And radioactive substances release one or more types of ionizing radiation when they decay. Can you remember what those three types are? Alpha, beta, they were both particles, and then gamma was a wave. And then, of course, some neutrons can also be emitted. And finally, to finish off, we need to understand what ionization is. And it says there, when an element gains or loses electrons. Remember when we were talking about ionic bonding, it was all about electrons gained or lost. That's called ionization. When an element gains or loses electrons so that the number of protons and electrons are no longer the same, the atom has changed into an ion, and we call that ionization. So hopefully, apart from the history of the atom, most of the stuff we've learned about today is not too new, but really important for you to be able to recall both in physics and in your chemistry exam. Take care, and look out for the next bit on Show My Homework.